Okay, these are the content of chapter 1. Okay, you know this. We have source, transmission system, and we have distribution system. It is load. If you want to ask question, you can just interrupt me, or you can just interrupt me. We have source. So I will not go through one by one or very detailed, because you have learned last year, right? Or um, during the first semester. Okay. I will only emphasize on the I think the important parts, or I think the part that you should grab, you should master on it. Okay, the rest you can read by yourself. Okay, what's the difference between EMF and potential difference? EMF is the electrical potential difference provided by an energy source like battery. Potential difference is a function of the location, and potential difference between point A and point B is calculated by subtracting the potential from A to B. Okay. Okay, so let's say we have A here. So let's say we have A, we have A. We have a resistor. Okay, so this point is A. This is A. Why this? So this is A, and this is B. So VAB is VA minus VB. Okay, or the voltage drop across this resistor is called as VAB. Electric potential difference is measured in volt. Is an electrical circuit, current flows from the higher potential to lower potential. Okay, so let's say B is connected to ground, so current flows from A to B, because at ground V is equal to 0. The important difference between EMF and potential difference is used in all energy fields. EMF is only used in electric circuit. EMF generated by a source like battery or generator. Potential difference between any 2 points, but EMF exists only between the 2 ends of a source. Sum of potential drops or potential difference around a circuit is equal to total EMF. So EMF is equal to potential drop of A. Let's say we have ABC, element of ABC. So EMF is equal to VA plus VB plus VC. Okay, the voltage across the terminal of a battery, for example, is less than the EMF when the battery supplies current. So terminal voltage is the potential difference at the terminals of the circuit. Even if there is no load, see the terminal voltage will be less than the EMF. V is terminal voltage, is equal to EMF minus I. Ri is the current flows through the circuit, and R is the internal resistance of the battery. Okay, so in this circuit, EMF is equal to V plus IR. Okay, the voltage drop across R, and IR is the voltage drop on the R, the small r. It is internal resistance of the battery. Okay, this one you can read by yourself. VAB is the voltage between point A and point B. Okay, so or we can write as VA minus VB. So VAB is the voltage drop across this element. Okay, it is uh, from it is the voltage of point A and B, or VA. If we have VA here and we have VB, so VAB is VA minus VB. VAB is the voltage drop across this element. This is voltage and energy. Okay, we have two types of voltage sources, DC and AC. DC is constant voltage with time. For example, we have a battery 12 volts, so it is a constant voltage. AC voltage is a voltage that varies with time. For example, electric generator, socket outlet. So let's say we have sine wave, so AC voltage reflect to that sine wave, voltage that varies with time. Okay. Apa ni? Okay, so let's say we have a sine wave. Okay, so this is AC. Why we call it as varies with times? Because at when t is equal to 0, so the voltage is equal to 0 volts. This is voltage. This is time. So when the time is half, when the period is half, the voltage is 0. So varies with time. Okay, we have two convention for direction of electrical current. The first is this electron flow direction. So meaning that current is out of the negative terminal. This is negative terminal, so current is out from here through the circuit and into the positive terminal. So from negative to positive. Conventional current direction, current is out of the positive terminal. This is positive, so current flows from here to the negative terminal. But in engineering course, we will use conventional current, meaning that current out from the positive terminal. Current out leave from the positive terminal, go back to the negative terminal. Electric current, the time rate of change of charge measured in amps. So I is equal to Q over T. Q is charge, measured in coulombs, and T is time in second. Okay, this is the unit and symbol. Electrical measurement instrument. This is multimeter. This is digital multimeter because numbers appear on the screen. This is analog multimeter where needle is used. Okay. This is how we measure current. We put the meter or ammeter or the multimeter series with the element. Okay. Let's say we want to measure the current flows through this resistor or the current flows through this circuit. So we put the ammeter in series with the resistor. Okay. This is circuit representation. Okay, most analog ammeters have a number of possible setting. Most analog ammeter have a number of possible settings for the maximum possible current that can be measured. For example, 2 amp. This is the setting or the ranges of the ammeter. The largest is 2 amp and then the smallest is 2 milliamp. We should always start by turning the setting to the highest possible rating. So let's say we have 2 amp here. 2 amp is the largest, the highest. So we must select the highest. If the ammeter reading is too small from the selected scale, then you can reduce the scale to get the reading. Okay, let's say if we select 2 amp and we cannot read the reading or the reading is too small, then we reduce to 200 milli. Okay, and then if still cannot read the measurement, so reduce to 20 milli and so on. Okay, it is important not to overshoot the maximum value that can be read. For example, if the current is about 75 milli, then the ammeter would be set to the 200 milli. Okay, because 70 milli, okay, if we select 20 milli, then the setting cannot measure, it will be maximum, so we select 200 milli. The ammeter will be set to 200 milli scale for the most accurate reading. Setting to the 220 milli will overload the ammeter and most likely open its internal fuse. It will blow the fuse. This is how we measure the voltage. Okay, we put the meter or voltmeter or multimeter parallel to the element. Okay, let's say we want to measure the voltage across this resistor, this R. So we put the voltmeter parallel to R. How to measure resistance? No need to connect the resistor with the circuit. Okay, just put the probe of the meter at any point. You can put this probe here and this probe, put it here. Okay. You know what is error, accuracy, and precision? Error is the difference between the true value and the measured value. Accuracy is the difference between the true or accepted value with the measurement. Precision is repeatability or consistency of a measurement. Resolution is the smallest increment of quantity that the meter can measure. Okay, so we have 3 decimal point here. So 3 decimal point is more, the resolution of this 3 decimal point is higher than this. We have active and passive element. Passive element not supply voltage or current. For example, resistor, capacitor, inductor, and transformer. Resistor, capacitor, inductor, and transformer. Active element or active component have their own power source. For example, voltage source, current source, battery, fuel cell, and so on. And we have two kind of sources, which are independent and dependent sources. Okay. The ideal independent source, okay, is an active element, must be active because it supply voltage or current. Provide a specified voltage or current that is completely independent of other circuit element. Okay, symbol for independent current source is, okay, for current source, the symbol for independent current source is the round, okay, round shape, as well as for the voltage source, round shape. This is DC source, DC source, this is DC source because plus and minus sign. Okay. So we have 4 types of dependent source. Okay, we have a voltage control voltage source, meaning that this is a voltage source, but the value of the voltage of this voltage source is controlled by a voltage. And then the second is current control voltage source. This is voltage source, but its value is depend on other current. Voltage control current source. This is current source, but its value is depend on other voltage. Current control current source. It is a current source. The value of this current source is depends on other current. Okay. Let's say A is a voltage source, but the value of this voltage source is depends on other voltage. It is V, the small v. Let's say yes, the small v. So this is the voltage control voltage source. Okay. B is current control current source, because this is current source, but the value of this current source is control or depends on other value of current. So this is current control current source. Okay, so this is we have one dependent source and we have one independent source. 5 volt is independent source, 10I is dependent source. The value of this voltage source is depends on the small I. Okay, so this is current control voltage source. This current control voltage source is depends on I. Any question up to here? Any question?
No.
Okay. Okay. No, and now let's go to other slide. Okay. Chapter 2 DC circuit. How many of us now? 16. Okay. So chapter 2, calculate power, energy, determine whether energy is supplied or absorbed, state and apply Ohm's law, series parallel, total resistance, KVL, KCL, mesh, and nodal analysis. Okay, these are the content of this chapter. Okay, the sign of voltage can be negative. 12 volt is equal to minus 12 volt if we if the negative sign is upper side and positive side is lower side. Okay, so this 12 volt is also equal to this minus 12 volt. Okay, this is voltage control voltage source. Why? Because this voltage source is controlled by other voltage. Okay, that's why we call it as voltage. Voltage control voltage source. What is the voltage? Vx. This is current source because of the arrow sign, but this is dependent source, so current source. But the value of this current source is depends on other voltage. It is Vx, so we call it as voltage control current source. This is current source because of the arrow sign here. This current source, the value of this current source is depends on other current, which is Ix. Okay, So we call it as current control current source. This is voltage source because the sign of negative and positive, the value of the voltage source is control or depends on other current, which is Ix. So we call it as current control voltage source. Okay, voltage source can be connected in series. In this connection, the voltage value is added if the sign of both voltage source is the same. Negative, positive, then we just add the value. Okay. So the total voltage here is equal to V1 plus V2. V1 plus V2. Apa ni? Apa saya punya pen ni? Okay, so the total voltage for this V1 and V2, let's say, so negative here, positive here. Okay, so the V total is equal to V1 plus V2. Okay, make sure that this V total is the sign of this V total is equal to the sign of V1 and V2. So negative here, positive here. So we can just add V1 and V2. Okay. Let's say the VT is negative here and positive. So what will be the value of this VT? What will the value of VT? Muhammad Zafran? Muhammad Zafran? Where's Muhammad Zafran? Left the class? Kishan. What's the value of V total here? Can answer, Asfa? Give me the value of VT. VT is equal to what now? Asfa? All you want to type, what is the value of VT? VT is equal to? Let's say V1, let's say V1 is 1, V2 is 2. So VT is equal to? Minus
Tak jelas lah, Doktor.
Soalan tak clear.
Soalan tak clear.
Dari tadi
saya tak nampak nombor.
memang. Okay. Good question. Let's say V1 is equal to 1, V2 is equal to 2 volts. So VT is equal to?
V1 equal to that?
V1 is equal to 1 volts. V2 is equal to 2 volts.
3 volt lah.
3 volt. It is minus 3 volts. Okay? Because of the negative and positive sign is different with this sign. Okay? Negative here but positive here. Positive here but negative here. So negative 3 volt. Okay?
Okay.
Pasal tak nak padam. Okay. So if we put the positive here, negative here, then VT is equal to 3 volt, positive 3 volt. Okay, voltage source cannot connect in parallel. It could easily cause component failure. It results in an inconsistent equation because let's say we have 3 volt here, we have 2 volt here, different value. Okay, so if we apply KVL, okay, if we apply KVL in this loop, okay, so we just add all the voltage source in KVL. We just add all the voltage source and make it equal to 0. Okay, so let's say we use the first sign. It is negative. So negative 3 and then plus 2 equal to
Negative
0.
Oh.
Okay, so 2 will be equal to 3, right? But 2 is not 3, right? So this is the proof why two voltage source cannot be connected in parallel. Okay. In this equation, we use the second sign. This is the second sign. This is the second sign. Okay. So positive 3 and negative 2. 3 minus 2 equal to 0. And 3 is not equal to 2. Okay. The battery with the highest voltage will discharge into the other one until they end up with equal voltages. If the second battery, the lower voltage one, is a rechargeable, okay, meaning that if 2 volt is rechargeable, then it will be charged by the first one again until the two have the same voltage, okay, meaning that 3 plus 2 divided with 2 equal to 2.5. So V1 should be 2.5, V2 should be 2.5. In this case, the end voltage will be intermediate between two starting voltages. The current flowing between the batteries during this process will be quite high. It is equal to the difference between the two voltage. Okay. So I is equal to V over R. V is equal to 1. Okay. Because 3 minus 2 is 1. So it is the difference between the two voltage. So 3 minus 2 divided with the R. Where is R here? R is the internal resistance of the battery. Okay. Okay, so this is example. Energizer alkaline battery has approximately 152 to 300 milliohms. Okay, let's say we take 150 milliohms. Okay, so we will get 3 amp. So 3 amp, any amount of current over 10 milliamps capable of producing painful to severe shock. Okay, so current between 100 and 200 milli are there. Current above 200 milli will produce severe burns and unconsciousness. Do not usually cause death if the victim is given immediate attention. So 3 amp is considered as high current. Okay, dependent. Okay, same goes to the current source. This 2 amp is equal to this minus 2 amp. Okay, you just put the arrow go down. Okay, this value of current source is equal to this. Okay, 2 amp is equal to minus 2 amp because the arrow is different. Current source cannot be connected in series because series circuit must have only one current, but it can connected in parallel. Okay, Ohm's law is what? Give me the formula for Ohm's law. Ohm's law is someone
V
want
equal
to
to IR.
V equal to IR. So
V equal to
Yes. Resistance is a characteristic of material to resist the flow of electric current. Okay, represented by R. The resistance of any material with a uniform cross-sectional area A depends on uh, A and length. Okay, so R is equal to rho L divided with A. So if the conductor, okay, let's say conductor is has high in length, so the resistance is higher. Okay, if the conductor has high A area, okay, so the resistance become lower. Okay, so this V, the voltage is on the y-axis, current is on the x-axis, and the slope is R. Okay, we have two short circuit and open circuit. For short circuit, okay, V is equal to 0 because R is equal to 0. Okay, this short circuit are no R, so R is equal to 0, but we have I current. Okay, so V is equal to I. Okay, we have I, any I times 0 R, so we have 0 volts. So for short circuit with no resistance here, the voltage is equal to 0. In practice, simple circuit, a short circuit is always a connecting wire assumed to be a perfect conductor, or we can call it as jumper. This is open circuit. For open circuit, R is equal to infinity. Okay. So in open circuit, no current flow. Okay. So R is equal to V. Let's say V is equal to 5 volt. V divided with I. Okay. So we have infinity. Any question? No. A short circuit is a circuit in which the electricity has found an alternative path to return to the source without going through appropriate load. Okay, so current flows from the source to the source, not flows through the load. Okay, so the wire will heat instantly and probably melts. Consider this figure. If the wire inside the drill comes loose and touch the other wire, the new path exists where the current can return to the source without going to the load or to the drill. So current from the source, okay, and these two wire touch, so the current flows back to the source. So this is unwanted short circuit. Another type of short circuit occurs when some conductive object accidentally gets into an overhead power line. If the object touches both the lines at the same time, the electricity has a short circuit path available to return to the source before it goes to the customer. If the object is connected to the ground, the earth can act as a short circuit path because at ground the voltage is equal to 0. Okay. Ohm's law V equal to IR, but for conductance, it is the reciprocal of R. So instead of R is equal to V over I, okay? Instead of R is equal to V over I, now R is equal to I over V. Okay, so conductance is represented by G. 。    。   。  . 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 。 . 。 。 . 。 。 。 。 。 。 。 。 。 . 。 。 。 。 . 。 。 。 . 。 。 . 。 。 . 。 . 。 Okay, consider this circuit. 30 volt voltage source, 5k ohm resistance. I is equal to 30 divided with 5k. G is equal to the reciprocal of this resistance, so equal to 0.2 millisiemens. Okay, and then power. So we have three formulas of power: P equal to IV or I square R or V square over R. Okay, V square over R. Okay, or V square G, because G is 1 over R. Okay, so V 30 times 6 milli and so on. This is very basic question. Okay, power is equal to VI or V square R, V square over R or I square R. Absorbing or supplying. For resistance, capacitor, inductance, it absorb power. Okay. So the power is positive. For the source, okay, current source, the source, so it supply power. So the power is negative. Passive elements such as resistor, inductor, capacitor will absorb power. If the current enters through the negative terminal of an element, so it supply power. If the current enters through the positive terminal, it absorb power. Okay, so let's say this figure, current enter positive terminal, so absorb power, positive power. For this figure, current, this current must enter here. Okay, so if you look at this current, the error is leave this point, meaning that it enter this point. Okay, enter the negative terminal, so supplying power. Okay. You just remember that for passive elements such as resistor, capacitor, inductor, that element absorb power. Okay, for source like current source, voltage source, it supply power. Okay, so this current enter the positive terminal. Okay, positive terminal of the voltage, so it absorb power. Okay, just multiply the voltage with the current. Same goes for B. Okay, this current enter this terminal, meaning they enter the positive terminal, so supply, absorb. And this C and D is supplying power because the current enter the negative. This current enter the negative. Okay, you can just write, let's say for C, you can just write 12. For D, you can just write 12 volt. Okay, and then you put in the bracket supplying. Okay, the law of conservation of energy. The algebraic sum of power in a circuit at any instant of time must be 0, meaning that in a circuit, okay, the summation of power is equal to 0. Okay, this is follow the law of conservation of energy. So power supplied to the circuit must balance the total power absorbed. Okay, meaning that power supplied must equal to the power absorbed. The total power supply must be equal to the total power absorbed. Okay, you can try this question. The power for 100 ohm plus the power for 150 ohm must equal to the power of 5 volts. Okay. So the power supplied by this 5 volt must be equal to the power absorbed by 100 ohm plus the power absorbed by 150 ohm. Okay. Please calculate the power absorbed by 100 ohm. Now. Nabila Atika. How to calculate the power absorbed by 100 ohm?
Doctor.
The
answer 0.25.
0.25. How you calculate?
V square over R.
V square over R. V squared. Okay. Let's say you V square over R. Okay. So what is the V of 100 ohm?
The V of 100 ohm. I just use the 5 volt.
Just use 5 volt. Okay, so the power for here is equal to V square over
R.
Okay, V square over R. So V is equal to 5 square divided with 100.
100, yes.
How about Nur Aiman? Do you agree?
Yes, Doctor.
Agree. How about Nur Izzah? Nur Izzah agree?
Yes, Doctor.
Agree. Asfa?
Doctor, can we use P equals to IR?
Yeah, why?
Because we find the total resistance first, and then we calculate the total current, and then we use P equals to IR. So we got 5 volt.
Okay.
So
That's
law of conservation energy proof.
okay. So you cannot use this equation V square over R here. Okay. Yes, you can use P of 100 ohm is equal to V square over R, but the voltage drop across 100 ohm is not 5 volt because 5 volt will divide to 100 and 150. Remember, we can find the voltage drop across 100 ohm by using voltage divider principle. Right. So, this method is wrong. We cannot use 5 because 5 is the total voltage for this circuit. Okay, it is the summation of voltage of 100 and 150. So, you may find a power here by using P is equal to IV. Okay, so I is equal to V over R. V is 5, R is 100 plus 150. Okay, and then so this is the I total. I total is equal to V over R. V is equal to 5 divided with 250. Okay, so and then you get the answer of total current, and then the P for
100 ohm.
100 ohm is equal to this current times 100 volt. Okay, same goes for 150 ohm, and then the power for 5 volt is equal to, yes, you can use V square over R. So V is 5 square divided with 100 plus 150. Okay, make sure that the power supplied by 5 volt is equal to the power absorbed by 100 and 150. Okay, so you calculate the power here. Make sure that the power of 100 plus the power of 150 equal to The power of 5 volts. Okay. So if you get the answer, so the law of conservation of energy is proof. Any question? Understand or not?
Understood.
Okay. Resistor. Okay. Resistor color code. We have 4 bands. For a resistor, this is the first band. Represent the first number, second number, and the third band is number of zeros, and the last band is tolerance. We have 5, 10, and 20% tolerance. Okay. This is in Malay. Haji pamak orang kaya hendak beli ubi kaya putih enggan pulang tanpa wang, as your teacher taught you during your secondary school. Okay. So this is the first band. It is brown and then black. The third band is green and then silver. So brown represent number 1. Okay, brown is number 1. So 1. The what is this? Black. Black is 0. So we put 0 and then green. Green 5. So 5 of zeros. 1, 2, 3, 4, 5. Okay. And then silver. Silver is 10%. So we put 10%. So the value for this resistor is we have 6 of 0. So 1 mega ohm, and the tolerance is 10%. So meaning that 1. So the we can accept the value for this resistor, okay, from 90, 100 kilo ohms to 1.1 mega ohms. Okay, because 10% of 1 mega is 90, 100 kilo. Okay, so 1 mega ohm plus minus 10%. So 1 mega ohm minus 10% and 1 mega ohm plus 10%. Okay, this is another example. Okay, and then this is capacitor. Unlike resistor which dissipate energy or absorb energy, capacitor store energy, which can be retrieved at later time. It is a passive element also called as storage element. So capacitor and inductor is storage element, but inductor store the energy in its magnetic field, but capacitor store the energy in its electric field. Okay, the unit for capacitance is farad. You can read this. How it store energy? This is the symbol for inductor. Okay, and this is how we read the value of inductor. Okay, this 2.7 we learn on this Thursday. So any question up to here? Any question?
No, doctor.
Okay, so I think let's try tutorial.
No, doctor.
Okay. Okay, tutorial 2. So they have to cover many parts. Okay. Okay, let's try. The voltage across 5K ohm resistor is 16. Find the current. Very easy. Find the hot resistance. Very easy. No need. Determine number of branches. Okay, so this one is. We are not covered it yet. So, how about we continue our lecture? Can we continue?
Sure.
Yes,
Sure.
sure, Doctor.
Okay. Okay, because you have learned it. Yeah. You have learned it. Okay. Last year and maybe last 2 years. Okay. So I think you can absorb better for this semester. Inshallah, right?
Inshallah.
Yes, Doctor.
Make sure A for this semester. Okay.
Inshallah.
Of course.
Of course.
Hmm. Okay, so we have terms of nodes, branches, and loops. Okay, branch represent a single element, such as we have voltage source, resistor, and so on. A node is a point of connection between two or more branches. So we have one node here. Okay, it is interconnection of 1, 2, 3 branches. Loop is loop, closed loop path. Independent loop is a loop that contains at least one branch. Okay, this is how we calculate branch. Branch is equal to loop plus node minus 1. This is the original circle. How many branches? We have 1, 2, 3. How many branches? 5. Okay, why 5? Because we have 5 elements here. 1, 2, 3, 4, 5 of elements. So 5 branches. How many nodes? We have A, B, and C. So 3 nodes. Okay. This is considered as one node because we can join it together. Okay, make it as this point, and this is ground connected together at C. How many loops? Just count the loops. We have 3 loops. Okay, for parallel circuit, we have the same voltage. Okay, so V1 equal to V2 and V3 because of parallel circuit. This is series circuit, so I1 is equal to I2. So only one current flows here. I1 equal to I2. Okay, we have KCL, KVL. It is Kirchoff's law. We have 2 types of Kirchoff law. Kirchoff current law, Kirchoff voltage law. Okay, so now let's start with KCL, Kirchoff current law. So it deals with current. Okay, states that the algebraic sum of currents entering a node is equal to 0. Okay, so when the current enter the node, so it is positive. When the current leave the node, so it is negative. Or you can write as current entering the node is equal to current leaving the node. So current entering the node is I1, I3, I4. I1, I3, I4 is equal to current leaving the node is I2 plus I5. Okay, what is current enter the node? I plus 4. Okay, I plus 4 is equal to current leaving the node is 5 and 11. Okay, and then we can find the value of I. Okay, we can sum all the currents of I1, I2, and I3 to become I total, IT. Okay, IT or IS. So IT is equal to, okay, IT. Okay, this is the node. Okay, this is one node. So what is current entering the node? I1 and I3, right? So I1 plus I3. What is current leaving the node? IT plus I2. IT plus I2. So IT plus I2 is equal to I1 plus I3, and then we can find IT, I total. I total is equal to I1 plus I3 minus I2. Any question?
No.
No,
Okay,
doctor.
good. Okay, no. Now we have a single node here. It is A. All these branches can be connected together to form a node of A. Find V node and I node. Okay, so since we learn about Ohm's law only. So in this example, we just use Ohm's law. Okay, actually, we can when we learn more technique, more apparatus, more circuit theory, we can just solve this by using nodal analysis. Okay, so if you apply KCL at node A, okay, KCL is current enter equal to current leave the node, or summation of current entering a node is equal to 0. So here current entering the node is 6. Okay, what else? Only 6, right? So 6 is equal to current leaving the node is I naught plus I naught over 4 plus current here. Okay, so 6 equal to I naught plus I naught over 4 plus this I. Let's say this I is equal to Ix. Okay, let's say I here is Ix. And we know that I naught, where is I naught? I naught is here. I naught is equal to V naught over 2. Okay, because parallel circuit, right? So the voltage across 2 ohm is equal to the voltage across 8 ohm. The voltage across 8 ohm is equal to V naught. So I naught is equal to V naught over 2. Okay, and Ix is equal to V naught over 8. So 6 is equal to I naught is equal to V naught over 2 plus V naught over 8 and plus this one. This one is okay, sorry. This one is I naught of okay. This value of current is equal to I naught over 4. I naught is equal to V naught over 2. So V naught over 2 times 4. So we get V naught over 8. Okay, so this voltage this current is equal to this current, and we get V naught. Okay, please rearrange, and then we get V naught is equal to 8 volt and I naught is equal to 4. Can you understand? Can you understand?
Yes, doctor.
Okay, good. Okay, the next is KVL. KVL is Kirchoff voltage law. It states that the algebraic sum of all voltages around a closed loop is 0, meaning that the summation of voltage in a loop is equal to 0. Okay, or sum of voltage drops equal to sum of voltage supply. So in this circuit, in this example, the voltage supply is V1 and V4. Okay, so V1 and V4 is the supply voltage, and the other voltage are the voltage drop, okay, on the element. So V2, V3 and V5 is the voltage drop. Okay, so current flows like this. Okay, so the voltage drop, how to put the notation of positive and negative? It follows the flow of current. Okay, now current flows like this, enter this resistor, so the voltage must be positive and then negative. Same goes for this, positive and then negative. Okay, flows through here, enter this element, so the voltage notation must be positive and then negative. Okay, then this is the KVL equation. You can use either the first sign. Okay, this is the first sign, negative, positive, positive, negative, positive is the first sign, or you can also use the second sign. Okay, for V1 the second sign is positive, the first sign is negative, so positive, negative, negative, positive and negative. Okay, let's say we use the first sign for this equation, so negative V1 plus V2 plus V3 minus V4 plus V5 is equal to 0. Okay, so this is the KVL equation. This is the original circuit, this is the equivalent circuit. Okay, so we want to find VAB. VAB is the total voltage of V1, V2, V3. Okay, but you cannot just add them together, you must observe the notation of or sign of the voltage source. Okay, if you look at this V1, V2 and V3, the same, the sign is different, positive, negative, negative, positive, negative, positive, so you must beware. Okay, we apply KVL. Okay, always draw the KVL arrow in clockwise direction. Okay, so let's say in this equation it use the first sign. Okay, negative, this is the first sign, negative VAB, right? Negative, and then goes here, we use the first sign, right? So plus V1, okay, plus V1 and then plus V2 and then minus V3 equal to 0. So VAB is equal to V1 plus V2 minus V3. Or you can also use the second sign in your equation. Let's say we start with VAB, so the second sign is positive. So positive VAB minus V1 minus V2 and plus V3 is equal to 0. And then you rearrange, put VAB is equal to what? Okay. So I is equal to, we have two voltage source here, VA and VB. Okay. This is the arrow of current. In this equation, it use the first sign. Okay, the first sign is negative. So negative VA and then plus V1 plus VB plus V2 and plus V3 is equal to 0. Okay. So please rearrange, minus VA minus VB is equal to V1, V2, V3. Okay, so V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3, and then we get this equation, and at the end we get this I is equal to VA minus VB divided with all the R, all R. Okay, find V1 and V2. How many slides? Series circuit. Okay. So if we find Vx and V0, apply KVL. So this equation use the first sign, minus 35 plus Vx plus 2Vx minus V0 is equal to 0, and we know that Vx is equal to 10 times I, and V0 is equal to minus 5I. Why minus? Why minus? Because current flows, okay, from here and then enter this point. The V0 must be positive and negative here. But now, the notation of V0 is positive and negative. So, we must put the negative, meaning that negative is negative current. Okay. So, when the notation of voltage is positive, negative meaning that the current flows, okay, to this positive terminal, meaning that minus of this I. So minus 5I. Okay, substitute all the Vs and V0. So minus 35 plus Vs is equal to 10I plus 2 Vs. Vs is equal to minus 5I. Ni 2 Vs. Sorry, Vs is equal to 10I minus V0. V0 is equal to 5 minus 5I. Rearrange and then you get Vs and V0. Find the current and voltages. Okay. So in this circle we have 2 voltage source. How to find the current and voltages? Okay, let's say the question asks you to find the current and voltages in this circuit by using Kirchoff current law. Okay, so we apply KCL here. We have only one node here. Okay, so at this node, I1 enter the node, I2 and I3 leaving the node. Okay, so the equation is I1 is equal to I2 plus I3. And we know that I1 is the current flows through 2 ohm. Okay, and the current flows through 2 ohm is equal to the voltage flows, the voltage drop across 2 divided with 2, meaning that V1 here. So V1 divided with 2 is equal to I2. I2 is the voltage drop. Sorry, I2 is the current flows through 8 ohm, meaning that V2 divided with 8, and then plus I3. I3 is the current flows through 4, okay? So meaning that V3 divided with 4. Okay, and then please rearrange. Sorry, no need to rearrange yet. Okay. And then we have 3 unknown here, V1, V2, and V3. We need other equation to solve this unknown. So we apply KVL at loop 1 and loop 2. Okay. In loop 1, let's say this equation use the first sign. So minus 5 plus V1 plus V2 equals 0. Okay. V1 is equal to 5 minus V2. If we add in loop 2, let's start with V2. Okay. So minus V2 plus V3 minus 3 is equal to 0, and V3 is equal to 3 plus V2. Substitute, okay, this V1 in here and V3 in here, and we get any. Or you can just use your calculator to rearrange all the equation, okay, to become V1, V2, V3 is equal to 0, okay, to get what is V1, V2, and V3. Okay, the step will be easier when nodal analysis is applied because we will only have one equation. I think we stop here. So during our class on this Thursday, I want you to do tutorial 2, okay? Number 6. Number C and so on. Number C, 7, okay? Number 6, number 6, number 7, number 8, number 9, 10, macam semua je. 11, 12, 13, 14, 15, 16. That's all. Okay? Until number 16.